So here in this problem, it's given that A, B, and C form a geometric progression, and we are also being provided with a relation A raised to the power of x equals B raised to the power of y equals C raised to the power of z. We need to verify that x, y, and z, these three numbers, are in harmonic progression. So let us begin. Now we'll start with whatever we have been provided with. So here we are given that A, B, and C, they are forming a geometric progression. So these are in geometric progression. So that means that B squared must be equals to A times C. So this is this is a relationship between A, B, and C. Now what we'll do, we'll take the logarithm on both sides. So we'll take logarithm of B squared. This will be equals to logarithm of AC. We'll consider the base to be let's consider the base to be 10. Okay. Now, the moment we apply logarithm to b squared, we can apply the property being that if we have log of a raised to the power of b, with assuming that the base is 10, then this is equals to b times log of a. Means we can rewrite log of b squared as 2 times log of b. This will be equals to log of a times c. There is another property of logarithm. So whenever we have log of the product of two numbers a and b, that's simply equals to log of a plus log of b, which means the log of ac can be also expressed as log of a plus log of c. We're going to keep it aside. Let's label this as equation number 1. Now let's come to the relationship. So here it's given here that a raised to the power of x equals to b raised to the power of y. So we're only considering the first one. We will apply the logarithm on both sides. Logarithm of a raised to the power of x must be equals to logarithm of b raised to the power of y. Assuming both of the logarithm has the same base 10. Now we can apply the property log of a raised to the power of b equals b log a. So we should get x times log of a. Well, this will be equals to y times log of b. Fine. So that means log of a can be also expressed as y over x multiplied to log of b. Let's label this as number 2. And we also consider the other relationship, which is b raised to the power of y equals to c raised to the power of z. Again, taking the logarithm on both sides, we have logarithm of b with raised to the power of y equals to logarithm of c raised to the power of z. So we have y times log of b, and this will be equals to z times log of c. Now let's try to isolate c. So we'll get log of c. So log of c will be equals to y over z multiplied to log of b. We're going to label this as number 3. The reason why we're isolating log of c and log of a, because what we'll do, we're going to replace this value in equation number 1. So therefore, equation number 1 now becomes, we have 2 times log of b. So this will be equals to log of a. So log of a, we can replace it with y over x multiplied to log of b. Plus we have log of c, which we can replace with y over z multiplied to log of b. Now we can factor out log of b from both sides. So we have 2 equals to y over x plus y over z. And if we divide each of the terms with y, so we have 2 over y equals to 1 over x plus 1 over z. So here we're getting a relationship that 2 over y equals 1 over x plus 1 over z. This relationship tells us that 1 over x, 1 over y, 1 over z, these three numbers are in arithmetic progression. So if they are in arithmetic progression, then the reciprocal of each term, that means x, y, z, these three terms are going to be in harmonic progression. And we have successfully showed that x, y, z are indeed in harmonic progression.